Hello everyone, welcome back to Code with Cougar. In this video, we're going to talk about operations we can perform on a 2D array or matrix or a set of matrices. So the first operation we can perform is accessing the element of the array. We could access the elements of an array using their row and column indices. As we saw in the previous video, each element of an array has their own index value or shows the location of each element. The first value or the first element of a 2D array had a 0, 0 index value. So the first 0 means the number of row it is located, and the second 0 or the second index we provide shows the number of column. We saw that how to access the element of the array 2D array. We can also change the element of the 2D array. Once we access that, we can change it. Suppose this array is called A, so I can access A of 0, 0. I can set it to a new value. Say I want to set it to 20. So this way I can change the values of a 2D array. We can perform addition operation on two matrices. We can perform subtraction operation on two matrices. Same way we can perform multiplication on two matrices. We can get the transpose of a matrix. We can do a scalar multiplication on a matrix. Then we can get the determinant of a matrix. We can get the inverse of a matrix. We can perform row operation or column operation on a matrix. So basically there are plenty of operations we can perform on a matrix or 2D array, but in this video I'm going to talk about some of the most common operations we might need to perform on a 2D array or a matrix representation of data. So the first operation we are going to talk about is the addition of two matrices. So the addition of two matrices is basically straightforward. First, we are going to verify the dimension of the two matrices. They should be the same. Suppose we are giving M1 and M2. We want to add these two matrices. First of all, we have to verify whether they have the same order or no. So this one is a 2 by 2 matrix, and this one is also a 2 by 2 matrix. So they have the same dimension and the same order, so we can easily add them. We also learned that this 2 means the number of rows. So this 2 array has basically two elements or two arrays. Each array has two columns, or each array has two elements inside that. So this is going to be the first array, and this is going to be the second array. Each array has two elements, 1, 2. So that's why we say 2 by 2 matrix or 2 by 2 2D array. To add a 2 by 2 array or two dimensional arrays or two matrices of the same order or the same dimension, we can simply add the corresponding values. By corresponding values, I means that the value located at the same index value of the first array, we gonna directly add it to the value located at the same index of the second array. So at the 0, 0th location of the first array, I have 2, and at the 0, 0th location of the second array, I have 1. So what I can do is I can create a new array of same dimension, a 2 by 2 array. Let's call it result. So in the result, so I'm going to add corresponding values. So this value 0, 0 location is going to add to the 0, 0 location of M2. So 2 plus 1 is going to be 3, and we added to 0, 0 location of the result. Then I'm going to add the 0, 1 location of the M1 or matrix 1 to the 0, 1 location of M2. So 3 plus 2 is going to be 5, and I'm going to add it to the same location of the result. Same way I'm going to add 4 and 0. 4 plus 0 is 4, and 5 plus 5 is 10. So this way we can add two matrices. So let's write code for adding two matrices. I have already written the two matrices I want to add. The first matrix is M1 and the second matrix is M2. So before doing that, let me define a function so that we can print our matrices each time instead of writing the two for loops each time. So we are going to define a function so that we can easily call that function. So I'm gonna define a function public static void. This function doesn't return anything. Let's call it print. This function takes a 2D array. We can define a 2D array by providing a comma inside the square bracket. Then the name of the array, let's call it matrix, the 2D array. Then using the two for loops, we can print the elements of the array. So let me define the first for loop for int I equal to 0, I less than matrix dot column 0, get length of 0. So get length of 0 basically gives us the number of rows. First, using the first outer loop, we are going to loop through the rows of the matrix. Then using the inner for loop or second for loop, we are going to loop through the columns of each row. So for int j equal to 0, j less than matrix dot get length, we pass 1 to get the number of columns. So inside this second for loop, we are going to print matrix of I comma j. So let's use a only right line. So we want to print each element at the same line of each row. So I'm gonna provide a space between each element. After the first row is printed, so this inner for loop will terminate. So then after the first row, I'm going to print a new line so that it looks nice. Let me call my function here and print matrix 1. Cool. It prints matrix 1. To add the elements of two arrays together, again I'm gonna define a function. So let's define a function public. This function is going to be static and it returns a 2D array. So I'm gonna give a 2D array instead of void. So this time we are going to return the result of addition of the two matrices. Let's call it add. This function takes two matrices, int matrix 1, let's call it matrix 1. Then it's going to take another matrix, let's call it matrix 2. So inside the function, we are going to add the two matrices. So before adding the two matrices, let's first check whether they have the same dimension or no. If they don't have a same dimension, we are not able to add that. Say one matrix is 3 by 2. 3 by 2 and the second matrix is 2 by 2. So in that case, we cannot add these two matrices because they don't have the same order. So before adding or doing anything, we gotta check for the order of the two matrices. So checking the dimensions of the two matrices. So to do that, I'm going to use if statement. So I'm going to first check whether they have the same number of rows. So I can get the number of rows using the getLength method and passing 0. So I'm going to do matrix 1 dot getLength method. I'm gonna pass 0 here. So the number of number of rows of the first matrix is not equal to the number of rows of the second matrix, matrix 2 dot get length. I'm gonna pass 0 here. Or if they don't have the same number of columns, so we are going to check the number of columns. Matrix 1 dot get length of 1 not equal to matrix 1 dot get length of 1. So if this condition is not true, so we are going to just prompt the user with a message. The matrices do not have the same dimensions, and we just return an empty two-dimensional array. Return new int of size 0, 0. So after we checked everything, both arrays has the same dimension. So let's get the number of rows and columns of either of the matrix since they have the same dimension. So I'm going to define an integer called row, number of rows in the given matrices. So I'm going to use matrix 1 dot get length of 0. Then I'm going to get number of columns by defining an integer value column and get the number of columns. So next I'm going to define a new 2D dimensional array called result to store the result of addition of the two matrices. So I'm going to define int 2D array, let's call it result equal to new int of row column. So we are defining a new array, 2D array of the same size as either matrix 1 or matrix 2, because they all should have the same size. Then I am using two for loops to loop through the elements of either of the matrix, or we can use row or column to loop through. So let's use the row and column for int I equal to 0, I less than row I plus plus, or either I can use, instead of row, I can use matrix 1 dot get length. Both of them are the same. Okay, let's use the inner loop for int j equal to 0, j less than column, and j plus plus. So each time I want to access each indices of the matrices, and I'm going to add them and store them in the result of the same index location. So result of I comma j equal to matrix 1 dot matrix 1 of I comma j plus matrix 2 of I comma j. So this way we can add the two matrices. Once we add the two matrices at the end, so I'm going to return the result matrix. So this way we can add the two matrices. Hope it works. Let's print matrix 1, let's print matrix 2, and let's print the result adding matrix 1, add matrix 1 comma matrix 2. So this add function returns a two-dimensional array, and I'm going to pass this two-dimensional array directly to our print function, so it will print that. Okay, so let me put a new line after each matrix is printed. Let me print a new line here. This should go inside the function. Okay, so this is matrix 1, this is matrix 2. So 1 plus 9 is 10, 2 plus 8 is 10, 3 plus 7 is 10, cool. 4 plus 6 is 10. So looks like our addition works. So if we want to perform subtraction is same as the addition. We have the same rule. Only we can do is we can, suppose I want to subtract m1 from I want to subtract m2 from m1, so I can subtract 2 minus 1 is going to be 1, and 3 minus 2 is going to be 1. So 4 minus 0 is going to be 4, and 5 minus 5 is going to be 0. So this is going to be the result of my subtraction. Same as addition, both the arrays should have the same dimension and same order, 2 by 2 or either 3 by 3. So what I can do is here I can copy this addition method. I can simply bring some changes here. Let me copy that and paste it here. Let's call it subtract. It takes two matrices, matrix 1 and matrix 2, so we are going to check for the dimension of the matrices. Cool. And here I want to subtract matrix 2 from matrix 1, so I just simply replace this plus sign with a minus sign. So let us print that instead of add. Let's call subtract this time. So it should have a T also, subtract. So if I run my code show I should get 1 minus 9 is going to be minus 8, 2 minus 8 is going to be minus 6, 3 minus 7 is minus 4, 4 minus 6 is minus 2, 5 minus 5 is 0. Cool. So this way we can add or subtract two matrices from each other. Next, let's talk about transpose of a matrix. Basically, transpose of a matrix is obtained by interchanging its row with its column. The operation basically flips the matrix or a 2D array over its main diagonal. So when we want to get the transpose of the matrix, we basically change the rows of the given matrix, in this case matrix M, and the rows become column, and the columns of the given matrix become the rows of the new matrix. So this way basically we flip the array over its diagonal. So we can in matrices we denote the transpose of a matrix by its name and superscripting it by T. So the transpose of this given array, since we have a 3 by 2 array, once we flip that and change the number of rows and columns, so the new result or transposed 2D array we are going to get is going to be a 2 by 3 matrix, where it is going to have 2 rows and 3 columns. In the given array we have 3 rows and 2 columns, so to flip that or get the transpose of that, the first row becomes the first column of the new array. So 1 5 is going to be the first column. 2 7, which is the second row of the given array, is going to be the second column of the new array. So 2 7 is going to be the second column, and 9 8 becomes the third column of the new result or transposed array. So this way we can get the transpose of a 2D array. To do that, let's write code in C# to get the transpose of an array or 2D array. Again, I'm going to write another function. Let me delete this one. Here we have the add function. Let's write another function to get the transpose of matrix. So I'm going to do public static. This again going to return a 2D array, which is the transposed array. Let's call it transpose. This takes a 2D array. Let's call it matrix. So inside this function, first what I'm going to do is I'm going to obtain the dimension of the matrix. To get the dimensions of the matrix, we can do is we can define a row and a column variables. I'm just gonna copy this one. First I'm going to get the number of rows we have and the number of columns. Then I'm going to define a new matrix. Let's call it transpose or result. And 2D array transpose equal to new int of row column. We don't want int of row column, but instead we want int of column row, since we are interchanging the number of rows and columns. So the new array or transposed array is going to have the opposite dimension of the given array. So to do the transposing, we are going to loop over the elements of the given array using a for loop for int I equal to 0, I less than a row, I plus plus. Then I'm going to use the inner loop for so here inside the second for loop I'm going to flip transposing the matrix by interchanging row with column. So to access or get the elements of the given matrix, we can do matrix of I comma j. We know that. So the I comma j item of the given matrix is going to be stored in j comma I of the transpose matrix we define here. So I'm going to say transpose of j comma I equal to a matrix of I comma j. So the item at index I of comma j of this matrix given becomes j comma I. So the row becomes column and the columns become row. So this way we can get the transpose of a matrix. At end I'm going to return the transpose. So let us get the transpose of matrix A. Print transpose of matrix 1 or matrix. Okay, let me print that. Okay, so here I have a 3 by 3 matrix. So 1 2 3 becomes the first column, the first row becomes the first column. 1 2 3 4 5 6 4 5 6 7 8 9 7 8 9. So let me change this matrix a little bit. Let me delete one of this rows so that it becomes 2 by 3 matrix. So we have a 2 by 3 matrix here, and the transpose of that becomes 3 by 2. So the first column becomes the first row, the second columns become the second row, and the third column of the given matrix or 2D array becomes the third row of the new transposed 2D array. Next, let's talk about a scalar multiplication of a matrix. So basically, a scalar multiplication of a matrix involves multiplying every element of a given matrix by a scalar value or a single number. Say I have a simple matrix here, 2 3 1 4. So I want to multiply this matrix to a scalar value. Say I want to multiply it by 2. So what I can do is I will multiply each element of the matrix to 2 and store it in a new matrix. So this is going to be a 2 by 2 matrix, and the result is going to be a 2 by 2 matrix also with the new elements. So I'm going to multiply 2 to 2 and store it at the same index location. So 2 into 2 is going to be 4, 3 into 2 is going to be 6, 1 into 2 is going to be 2, and 4 into 2 is going to be 8. This way we can multiply a matrix by a scalar value. To do that, it's going to be a super simple operation. What we can do is, say we have these two matrices. Let's define a quick function, public static. This function is going to return a 2D array. Let's call it S multiplication. This takes an integer, a 2D array of integer type, and also it's going to take an integer value, a scalar value. Then inside this function, either we can create another result 2D array, or we can use this matrix one. Let's use the same matrix. We are going to loop through the elements of the matrix for int I equal to 0, I less than matrix.getLength 0, and inside the inner for loop, so I'm going to use for j++. So here what I'm going to do is I will do matrix of I plus j. I comma j is going to be equal to multiply equal scalar, so it's going to multiply each elements of the matrix by this scalar value and store it back at the same location. This operation is same as if we say equal to matrix of I comma j into this scalar value. So this is going to multiply each element with this value and store it back at the same location. So at the end, let's return our matrix. So let me print matrix 1, and let us call the function S multiplication. Let's call matrix 1, and let's multiply each value of matrix 1 by 2 and print that. So we can see matrix 1 is 1 2 3, 1 into 2 is 2, 2 into 2 is 4, 3 into 2 is 6, 8, 10, 12. So this was some of the most common operations we can perform on a 2D array or a matrix. Thank you guys for watching and see you in the next video. Bye bye.